Student friends, once again, with the gap of a week, we are meeting here to start with paper number 12, Electronic Communication, topic 3, namely antenna and radio wave propagation. Friends, we are going to start today the new topic, which is antenna and radio wave propagation. Student friends, already we have studied the modulation and demodulation aspects in topic number 2, and we are aware that modulation is the process that takes place in the transmitter, whereas demodulation is a process that is necessary in receiver. Basically, transmitter is used to transmit the information and receiver is used to receive the information and to reproduce it at the destination. But in between transmitter and receiver, what is going to happen for the transmitted signal till it is going to be received at the receiving end, and that is what we are going to study today in the topic antenna and radio wave propagation. Friends, you might be seeing antennas for the television, for the radios, which are used to transmit and even for receiving the signals. If you visited to any television transmission center, there also antennas are going to be located. It possesses the transmitting antenna as well as the receiving antenna. Thus, transmitting antenna is connected to the transmitter, whereas the receiving antenna is connected to the receiver. And in between transmitting antenna and receiving antenna, after the signal has been transmitted, what is going to happen? How the signal travels from transmitting antenna towards the receiving antenna, that aspect we are going to cover in today's topic. Means we are interested to study how the signal travels after being modulated in the transmitter up to the receiver. During this particular process, what is the role of transmitting antenna and also what is the role of receiving antenna, and what are the different paths which are available to travel the signal from transmitting antenna towards the receiving antenna. We are going to see how the signal passes through the space, how the signal passes through the atmosphere, how the signal passes through the cable, whether the cable is simple coaxial cable, television cable or optical fiber cable. So all these are the media that carries the radiations transmitted by the transmitting antenna up to the receiving antenna. In between that, how wave is going to travel, and that's what we are going to study in the today's topic, and the topic is known as antenna and the radio wave propagation. Student friends, let us make our plan to proceed with this particular topic. We are going to divide this topic into two parts. First is antenna and second one is radio wave propagation. In first part we are studying the antenna. We are studying its introduction. Then we are going to study the basic principle of antenna, how antenna works. Then what are the antenna parameters which are going to decide the performance of antenna or characteristics of antenna, with which we are going to say that the antenna is going to act as a perfect transmitter and antenna is going to act as a perfect receiver. So for that particular purpose, which are the parameters which are responsible for those antennas? Then we are going to study the type of antenna, where we are going to study three types of antenna. One is the basic antenna, that is a half wave dipole antenna. Second one is a Yagi antenna, and last one is the dish antenna. Friends, half wave antenna is the basic antenna. Yagi antenna nowadays it is not looking at all, but some 5 to 10 years back, Yagi antenna was efficiently used to receive the television signal from the television transmission center on our television kit. Now this Yagi antenna is everywhere replaced by means of a dish antenna, which are made up of the different companies. So we are going to study these antennas in detail. After that, in second part, we are going to study the propagation of the radio waves, where we are introducing the radio waves. We are going to study different paths of propagation of the radio waves. In that, we are going to study details of the ground waves, how they carry the information from transmitting antenna towards the receiving antenna. We are also going to study the space waves, means how the space waves are responsible to carry the information from transmitting antenna and receiving antenna. Then we are going to study the tropospheric waves, and also we are going to study the sky waves. By using them, how the information from transmitting antenna will be received towards the receiving antenna. Then especially we are going to study the concepts of virtual light and also the skip distance, that plays a very vital role in the propagation of radio wave by means of especially sky waves. So this is how we are going to plan our lecture to proceed with the topic known as antenna and radio wave propagation. Students, to proceed further, let me introduce the antenna. First, Without antenna, the communication of the signal information towards the receiver is not possible. In other words, we can say antenna plays the very vital role to transmit the signal and also to receive the signal. To transmit the signal and also to receive the signal, same type of structure we are going to use. And that same type of the structure which we are using, and that is known as antenna. Nowadays antennas are available in most of the places. Antenna is available for the mobile even also. Antenna is used in radios. Antennas are used for the television communication. You are going to observe the antenna on the top of four-wheelers, that is on the top of the cars. At the cost of that only, we are going to listen FM stations, AM stations while traveling in our journey. All these examples makes us to clear that antenna does the very vital role in the process of signal communication from transmitter towards the receiver. Again, try to remember, antenna is the similar type of the structure, same type of the structure that can be used for the transmission purpose, and also same can be used for the purpose of the receiving purpose. So what is that similar type of the structure? So that similar type of the structure is a conducting metal rod, a conducting metal object, a conducting group of wires, may be made up of copper or may be made up of the aluminium. These may going to act as an antenna. I hope you are going to understood. A group of wire, copper wire especially, a conducting metal rod is going to act as an antenna. It may going to receive the signal, also it may going to transmit the signal, depends upon how it is going to be located in a space. Thus we can say such a group of wire may be in a particular shape, may be in a particular size, or a conducting rod, metal rod, which is connected to the transmitter or it is connected to the receiver. It couples the signal from transmitter to the space, or it couples the signal from space to the receiver. Means it is a device which is used to couple the transmitted signal to the space, and also it couples propagating signal from space to the receiver. And to perform both the functions, the structure of coupling device is the same. That coupling device we can call it as an antenna. Antenna not only does the job of coupling, as we are aware that in a transmitter the process of modulation takes place. high frequency signal is generated, and that high frequency signal may be available in a radio frequency range. It may be available in VHF or UHF range, and to travel this signal through this space, it should be converted from radio frequency signal into electromagnetic radiations. And this function is also done by means of an transmitting antenna, or the antenna which is connected to the transmitter. The reverse case, the antenna which is coupled to the receiving antenna, it receives those electromagnetic radiation traveling from the space, and those are converted into again radio frequency signal back for the analysis of the receiver. And such a device that converts radio frequency signal into electromagnetic radiation, and also, if necessary, electromagnetic radiation into radio frequency signal back, that structure we can call it as an antenna. Friends, when radio frequency signal is going to be converted into electromagnetic radiation, it travels in the form of a wave that contains the energy in the form of signal to be transmitted. Even though at the wastage of some amount of energy during the traveling process. When the signal is transmitted or radiated, it produces the one wave, and when we can say as the signal transmits, travels means propagates from transmitting antenna towards the receiving antenna, it will propagate in the form of the wave, then we can say it possesses the wavelength, and that wave travels with the velocity that is equal to velocity of the light radiation, because RF signal is going to be converted into the electromagnetic radiations, and the properties of the electromagnetic radiations are same as that of properties of light radiations. That means these electromagnetic radiations may going to reflect, may going to refract. All these properties are going to be associated with the electromagnetic radiations, which are also true for the light radiations. And hence we can say these electromagnetic radiations carrying the information, carrying the energy, will travel from transmitting antenna toward the receiving antenna in the form of the waves possessing certain wavelength, travels with the velocity equal to velocity of the light, that is 3 into 10 to the 8 meter per second. It has its transmitted frequency, because in transmitter only the signal is modulated, means low frequency modulating signal will be converted into high frequency signal, means that transmitter possesses a transmitting frequency. If we know the transmitting frequency f, and if you know, obviously, as the electromagnetic radiation travels with the velocity equal to velocity of light, that is 3 into 10 to the 8, if you know the velocity and if you know transmitted frequency, one can definitely determine the wavelength of the wave that travels in a space from transmitting antenna towards the receiving antenna. This is how the role of antenna is very vital in converting RF signal into electromagnetic radiation and vice versa at the receiving end. Details of the same structure, to which we are going to call it as an antenna, we are going to discuss in further lectures. So let me describe the same or introduce regarding the antenna under the title known as Introduction. In order to couple output of transmitter to the space or to couple the signal from space to the receiver, same type of structure capable of radiating the electromagnetic waves or receiving them is necessary. Means we are using the similar type of the structure which is connected to the transmitter or which is connected to the receiver, which may going to radiate the electromagnetic radiations or it is going to receive the electromagnetic radiations. A similar type of structure is necessary. And what is that structure? An antenna is that type of structure. Maybe it is a metal object, it is made up of the metal, or a wire or group of collection of wire that converts high frequency signal into electromagnetic waves or vice versa. So for a broad understanding, what we can say, antenna is any metal object, a conducting wire, a group of wire that converts RF signal into electromagnetic radiation and also electromagnetic waves into the RF signal. That metal object we can call it as it is the antenna. Transmitting antenna radiates electromagnetic waves, travels through the space and are received by the receiving antenna that converts into high frequency signal. What is the role of transmitting antenna? It radiates the electromagnetic radiations into the space. They travels through the space and same are received by the receiving antenna and are converted again into high frequency signal back. The entire energy of radio frequency current doesn't travel up to end. Some energy will be radiated. In transmitter, the radiating circuit produces one wave of exciting voltage with the wavelength lambda is equal to c upon f, where c is the velocity of light or velocity of the electromagnetic radiation, that is given as 3 into 10 raised to 8 meter per second, and f is the frequency transmitted by the transmitter. In short, what we can say, if you know frequency f, if you know velocity of light which is standard, one can calculate wavelength of the wave which is transmitted by means of a transmitter, and that is capable to travel from transmitting antenna toward the receiving antenna. Friends, hereafter we are going to study detail regarding the antenna, how an antenna works. That we are going to study in the next period. Today we will stop here only.